let's get started on some programming. And again, if questions are coming in, I will go to those first. So I'm working on this Mr. Forth base.h thing, and I have a to-do list of things I want to do. I haven't touched this in like 6 or 8 weeks because I've been busy, so I'd like to get my head back around the state of this thing. So here, my to-do said come up with names, better names than small and big. So I think that's, yeah, I marked all of my functions as either small or big. And the point being the big functions would undergo linking and the small functions would be static as defaults, right? And then you can see here, there's like, okay, so what are those? So I'm making progress, but there's still a lot of stuff about this that's like quite, yeah. Here's keywords. Okay, so let's start making a list of how complex this still is. I've made some amount of improvement to simplify, but from the old base layer. But you can see I'm doing things like, okay, I have to include Mr. Forth base.h, Mr. Forth keywords.h, Mr. Forth os.h, and then I have to include Mr. Forth base.c with the big functions, right? We gotta do that. I'm just gonna start grabbing all of this stuff. It's like the boilerplate that I still have in the current setup. I also got all of this, but some of this I'm going to... some of this I don't want to roll back into base layer. So I used to have buffer operators and the pseudo-random number generator were living in base.h. And I don't necessarily think that's where they belong, but there's also some complex stuff with the signal processing, audio processing, files interdepending on each other. XFZAC asks, will the Mr. Forth base.h be part of the membership program? As in, do we have to be a member to be able to access it down the road? And yes, thank you for the comment as well. No, so here's the deal. I want to be able to keep as much of the stuff I do free, especially the stuff that works better that way, right? So video content, I think, especially like educational stuff is at its most valuable when it's available for free to like students who aren't going to be paying for stuff unless it's, they're not going to be caring about educational content that's behind a paywall. I know there are some people who will pay for a course, but I want to get it out to as many people as possible. I'm trying to like spread the word with most of the stuff I do on video format. Now with code, it'll be sort of mixed. If I'm doing something like Mr. Forth base.h, that is going to be open source code. Because I think that it is more valuable to get to the point where I can put all my different projects on my base layer and just have my base layer be easy to use and easy to reuse. And if I have some open source projects on my base layer, then the base layer is going to have to be open too, right? So just the base layer has to be open. It's also very valuable to a lot of people as a good starting point. It's also already kind of open. It's just I have the Mr. Forth base.h is just a little bit more refined reuse. So that part's going to be open. And if you want to keep the open source stuff that I'm doing alive, then you could support me just because you like the open source stuff. But there will be some things that'll be closed source that I'll sell, and you'll get access to them only by being a member. I'll kind of announce that as I'm working on separate projects, which ones are going to be open and which ones are going to be behind the paywall. But Mr. Forth base.h definitely going to be free and open for everybody. Okay. No, leaving these out for now. Leaving those out. Okay. Okay, so this is the boilerplate for the base layer so far. And it's not bad. I like this stuff is actually a lot worse, but I think we should try to get down to just include Mr. Forth base.h. So here we have current boilerplate, and we have desired boilerplate include Mr. Forth base dot C with define Mr. Forth base big impl or something like that, right? So we probably want just that. And the reason we want this still is we might also change this big small thing. Do I have, unfortunately, I don't have my tablet set up today, so I can't draw you a diagram of what I'm thinking, unless I use my mouse, but those don't turn out very well, or else they take a really long time. I also need to find I need to find the cloth for wiping down the, give me a sec, I'm gonna rearrange here. Where is that cloth? It looks like it did not move in with the rest of the tablet, so yeah, have to get the tablet set up again. But for now, I want to think through. I'll just have to think out loud here and try to make sense of it. Maybe we can do some ASCII diagramming. That might be good enough. So when we're looking here and we see small and big, so keywords, M4 link internal. Where does that come from? Right, I see that it exists there, but where is it defined? Functions, M4 link internal. I don't see anyone defining M4 link internal. Okay, here it is. Base.h says that M4 link internal is static. So that's a little weird. I want to get the naming scheme to be consistent. These M4 things. Do I have a lot of M4 things? These are all usage sites. Usage sites. Usage sites. Usage sites. Define. Yeah, okay. So the definitions. Those are usage sites. Okay, definitions. Okay. It looks like those are the only ones that I did that. So I'm going to fix the naming scheme here. That's where we're starting. We want to rename for these renaming problem. Let's consider the naming for these macros. Read only and no instrument. Okay. So if something is marked as internal, then what we're saying is it is not exported from .obj file, right? This is static. This is not exported from the obj file. If it's link external, then we're saying it is exported from the obj file. This is extern, C linkage, etc. No linker. Right. Okay. These are just our thread local variables. Easy enough. Okay, so these are exported from .exe.dll binary file. Read only data section, no instrument. prevents auto instrumentation on Clang. So I'm not sure. Do I want that? That seems a little off. I do want to keep the note of how to do no instrument, but like it's not even being used anywhere. Where is my profiling? Are any of these using like no instrument or anything like that? So this is a thing for auto instrumentation, which only kind of half works right now in my setup. This tells it not to do automatic instrumentation when you put it on a function, so it won't. The compiler won't generate basically the begin and end timing spots in your function. Just to fully explain, you can set an option on Clang that will tell it to generate instrumentation that marks the begin time and end time of each procedure, just all of them. And this, if you put this on a procedure, blocks specific procedures from getting that. So it's a very narrow, specific use case, and I'm kind of feeling like I don't understand how it fits in. So I'm gonna, if that is something I want, I'm gonna have to figure it out again. I'm gonna just lose it because that seems a bit extra. Now the rest of these, I definitely want read only. That's fine. Scope thread is a weird name. The reason I didn't call it something else is like, I guess I could call it like thread variable, right? That would just be very direct. I think that is better. Gobsmack Goose question: any more future developments, thoughts with the story engine? Really enjoyed the concept and series of videos. Yes, I have more thoughts. So I was doing some experiments, and I kind of I reached a point where it felt like the experiments were getting far enough away from the direct effects that I care about. So basically, with the story engine, just to catch everyone up, I'm looking for a way to kind of make a programmable system where you kind of program a story into a game, or you program a story game in a way that feels like it sits halfway between writing and programming, so that you can create interactive fiction type experiences that have more rich qualities than what you get out of a standard like pick a path adventure story. And so I was exploring like what kind of model you might use to do this blend between writing and programming. And as I was iterating on it, I was getting farther and farther away from achieving the direct effects that I cared about, and more into esoteric programming concepts that seemed like they might be a good basis for solving some of the problems. But I kind of felt like I got to a point where it might just be easier to do a fresh, just start from scratch and build the story game without an engine again, because I did that once, and I kind of got to a point where it felt like my next step needs to be to do another fresh story game in C with no engine, no helper tools or anything, because I have learned a lot just in terms of how I would structure that, and I want to sort of get a fresh feel for how far I could get just with that part. The other thing I've kind of concluded is that I think I was starting from the wrong problem. It is true that I want to make at some point sooner or later, we're probably going to have to make a nodes and wires data structure interface, like a thing for visually laying out boxes with wires between them for various kinds of experiments we're going to want to do. And once we have that, one of the things we could do with that data structure is more of the story engine stuff I had in mind. But I think there's this other thing which I've never really talked about that I've been thinking about a lot, which I sort of like a finite state programming system, sort of like a way of this. I don't know if you've ever had this experience, but there's types of programming. It happens in like, when you're doing stuff like type systems or debug information, dealing with like different types of like when you're looking at binary file formats, this stuff comes up sometimes, where you start having rather intricate enum programming problems, where you got like 20 enums that represent different things, and they kind of need to be split up into subsets that you can figure out, okay, for any given value of this enum, which class of the enum is it a part of, and sometimes you need like maps where you take in an enum and you map it to another one, or you take in a pair of them and map it to something, or you take in a class in an enum and you map it to something else in the class, or there's like all kinds of stuff that you start wanting to do with your enums, and programming that stuff out is pretty similar to like some of the stuff I want to do with story engines, like discrete logic of like, if you're in this combination of state like ideas, then this transform is what happens at this point. And so I've been thinking maybe that's the right starting point too. But yeah, that'll come back. That's a part of my experiment. That's one of the story engine's one piece of like experimental programming in my head. So we'll be coming back around to that. Second question from Gobsmack Goose: would the story engine repo be part of the membership? Yes. So since it is going to be much more experimental, and there won't necessarily be stuff that I'm like, hey, this is actually worth sharing to the whole world. If I have something that's like a dud experiment, then it doesn't need to be open source, at least not for the first few years, right? That can be behind paywall. I don't think that I'm like preventing it from achieving its full potential by putting half-baked experiments behind a paywall. If I come up with something that's really working well, then what I would probably do is not put it as a part of the membership, but turn it into a for sale package. And then, of course, if you are a member, you would use your credits to buy something like that. If you don't know about the credits thing, go and check out the page about the membership. And anyone who wasn't a member could just buy the story engine that way too. Right, so if I get a good one of the story engine, it would become for sale. If it was just like flops or half-baked ideas, then it would be behind the paywall for a while. A big like part of the philosophy of what goes behind the paywall and what doesn't is anything that would do like, there are some kinds of information, some kinds of code that matter more, that have more impact when more people have access to them, and some don't. So like code like base.h, if the more people who use it, the more like eyeballs on it, the better it gets for everybody. The more like libraries that can be built on top of it that will be able to integrate with each other very nicely, right? So having that in lots of hands makes it even more valuable. Having something like a half-baked experimental idea in more hands that kind of thing doesn't usually make much of an impact in my experience. So that's like how I'm making the determination. Yeah, it is like my own libc alternative, essentially. In fact, that would be cool as a part of the base.h. Ooh, I did not set up. All right, we're gonna have to do that. Forgot to run the Visual Studio setup script. Okay. All right. Oh, that means I lost my scratch. Ooh, I should have saved that. Okay. Let's just start from M for link internal. Yeah, okay. So we want to get this renaming problem. I'll just start from here. So we're trying to get, I'm going to get like shorter and more and names for these, and names that are more consistent with the rest of the naming scheme in the base.h. But to circle back around to what I was saying, oh, I already have it. C standard elimination. Yeah, we want to do like, can you build without clib entirely? I was already thinking that. Awesome. Gobsmack Goose, yes, combinatorics is a piece of it for sure. In fact, I think that was another idea that I have explored, that like something like a combinatorics programming system might be what I'm looking for. At least, so I thought about how a combinatorics programming system could be useful for like procedural generation and stuff. Like if you're building a card game, but you want something more than just drawing cards from a deck, you want all sorts of like intricate, hand-tuned, like we're not just drawing cards, but we're drawing cards of this particular class from an unordered set. You know, there's ways you could express that using the language of combinatorics, which I think would be a really interesting type of language. Okay, so we renamed threadvar. I think read-only is a good name. So these ones. Link internal, link external, dynamic export. So these are more like OB object sim baked, sim linked, sim exported. So I'm thinking like a symbol that's baked into the binary or into the object, a symbol that is linked with the linker, and a symbol that is exported. I don't like the word dynamic because dynamic and static are relative terms. You know, what counts as dynamic and what counts as static depends on what point in time you're standing at, right? Dynamic is the future and static is the past, right? So they don't always mean the same thing to everybody. This could also be called shared, but that's a little more confusing because you could think of this as shared too, shared between objects. Sim bake link load yeah, it's just this word here. What is this? Is this like binary? Runtime? Link time? Comp time? So like name the time when the thing gets resolved? What do y'all think of that? Zachary TQ asks, can you explain the differences between Mr. Forth Big, Mr. Forth Small, and the sim stuff you're working on now? Yes, I can. So big and small are sort of intermediate names. We might not actually need those once I've done a good job with the naming scheme here. But what's happening is, let's start with these. So these are just like the hard-coded here in my base layer. I've got to have some kind of way to say, like, how am I going to rename static and extern? I don't really need to rename static, but I don't like... The word static is so confusing, and so I want a keyword that means, like, internal linkage or compile time resolution or something, right? So this is just a hard rename. This is just a renaming for the purposes of using words that are more descriptive. And static, at least in C, static always means compile time linking. Yeah, in C++ it's weirder, so ignore that. You can see in this case though, like if depending on whether we're building as C or C++, we want to always have the same effect, which is we want to mark our external symbols as C linkage. So in C they're always C linkage. In C++ we have to mark them this way. But the point is this creates a C link. I call this C link time. But I'm not sure if I like that. Anyway, so these are just hard coded. They're sort of fixed. They don't change. They're not configurable, right? They're just names of these properties. The export one. So this one has resolve this symbol inside of the current compilation unit. This is resolve this symbol during link time. And then export here means have this be visible even as from outside of the DLL or exe file. From the final compiled binary will export this symbol so that it can be loaded in by another binary or executable, right, of some kind. So those are 3 different ways of marking a symbol for how you want to resolve references to that symbol. The Mr. Fourth Small and Mr. Fourth Big are the markup I actually use on my functions, right? So I'm marking up some functions as big functions and other functions as small functions. And then the idea is these are configurable. So if you want to, you could say like, hey, I just want everything. I don't care about compiling with multiple object files. What I want is pure Unity build. So let's just build everything as compile time. And then you would swap out Mr. Fourth Small and Big. And so the reason there's a distinction there is so that I have some names that are I have some names here that are marked as like non-configurable, so that they mean the same thing everywhere they show up. And I have some other names that are marked as configurable, so that you can mark a function as small or big, and that's sort of a hint that says if you were going to split this up into multiple object files, then these are the functions you would want to compile separately. Now, here's the thing about that, is it kind of adds in some complexity. So I could see an argument to say like, hey, don't do that. Just mark everything as a Mr. Fourth function and either compile them all big or all small, right? If you need separate object files, then just don't have any of these static ones. But, you know, these static ones are simple things like the string constructor and little helpers like these. These have such tiny little definition. This is literally taking 2 parameters, packing it into a struct, and returning the struct. Like, it's just stack manipulation stuff, right? These are like not that much more complicated. So having that defined in every object file isn't that much code to generate in it per object file. But on the flip side, it's still some code, right? And maybe it would be better to just say, if you're gonna have multiple object files, just stop this entirely, this whole linking across thing. And then if it's not fast enough, like if having to do the link time resolution across object files is a problem, then don't have multiple object files with that link together the base stuff. But that can be tough. Like, I have that sometimes, right? If we just look at my my build script here, like even the thing I was just working on has 2 compilation units because I need C++ for the MP4 out, but I want C for the flow effect, right? And so I really don't think you want to get into a world. I think Unity builds are cool, but I think if you take them all the way to the point of saying you're going to Unity build to the point that you cannot even accommodate 2 compilation units when it is useful to have 2 compilation units, like, I don't know. I don't want to rule out multiple compilation units, right? That said, I don't know the best thing to do with a base layer, because the base layer has these things that are like, okay, what, for instance, let's look again. The sign function in my base layer here, what is it doing? Well, it's one of them is just calling to the math.h, which, by the way, we want to replace that. We want to be able to have math implementation replacements. But right, this is if you have to link to this, then the compiler can't inline it, and this is perfect for inlining, right? So like some of these are more like saying, hey, why don't we just not put this through the linker, because I'm guessing that it's going to be better for compilation. So why don't we actually stop and have a more meta chat? You know, I like to talk about how things could be better by going big brain, pie in the sky kinds of ideas. So what do we really want? right? What I really want as a programmer is I don't want to have to mark up each function as small or big, because I don't know at a certain point inlining these no longer makes sense, right? Like this is a little bigger than this. Let me get a better example. This and this do not generate the same amount of code. This generates a little more code. And if we go to like straight, like this one, I've marked it as inline. That's generating like a fair amount of code though, right? So if this is getting inlined everywhere it's being used, then that's making even more code expansion, possibly. But I don't know. I don't know as the programmer. Only the compiler knows when it comes time to look at that function, whether it makes sense to inline it or not. And then if it isn't being inlined, then it might as well be linked across object files. But we don't tend to think of it that way, because we tend to think of object files as if they don't know about each other, right? So if I write all my code and then I say like some of these are so small you should inline them, and some of them are big enough that they should be separate and linked, like there should be one copy of it and it should be called to, then we want that to just work without having to mark things up. Now, if you do a pure Unity build, that's what you get, right? If you have one compilation unit, then there is never a linker. The question is just, does the compiler inline or not? But if you have two compilation units, now the compiler doesn't get to make a universal decision across both compilation units for whether or not a certain function is going to be inline or like separate, called, jumped to as a function call, right? And so I'm wondering if that is a solvable problem. Would it be possible to make a world, because the reason we might want multiple quote-unquote compilation units is to solve a specific problem, which is that, like in this case, I want C in one of my compilation units and C++ in the other compilation unit. And at the extreme, what I want is I want to be able to put in different compilers and then link them together. I think there's a limit to how far I understand how to take that with the object file, because at the level of an object file, we've already generated real machine code modulo some symbol resolution and relocation problems. And therefore, if you have two different compilers both run generating object files, there's no way, like, how would the two separate languages coordinate on a symbol that they have in common, right? So the reason to do two languages as separate object files and then link them together is that one of them can generate the definition for a symbol and the other one can call that. So you can have like foreign function calls, right? You can have your modern C-like language, whether that's Odin or Zig or JAI or whatever else. You can have a language like that, which has foreign function capability, and say this is going to depend on a symbol from another object file, and then that object file can be in a different language. As long as they all import and export by the same protocol, they can link. But maybe the problem is that we need to generate something higher level than an object file. What if, I think where my head is going is, what if each compiler generated IR of the same intermediate representation, right? If every compiler generated an intermediate representation file, then a back-end optimizer could mush them together, correctly deciding whether to inline or not. I think that's what it would take to get me out of the business that I'm currently in, of marking each function as small or big. But that was a digression. We got to make a decision. Do we mark things as small and big? It's so hard because I don't even know a way of testing if I've done a good job of marking them. So it feels to me like it's made up is my main concern, right? Like it's made up. I have no way of knowing if I've done a good job of marking them as small or big. So I think going back to the to-dos, let's finish renaming these throughout the code base, and then let's eliminate small big. I'm not sure if that's the right thing to do. I'm not sure if that's the right thing to do or not, but since I am unsure, having less detail is better. That's the default fallback. If it's ambiguous whether or not one way or the other is better, but one of them is simpler and involves less total detail encoded into the code, then take the one that encodes less detail. Gobsmack Goose, would the answer of this not keep shifting wherever you draw the actual boundaries of compilation? Yes, that's true. So it comes down to what counts as a compilation, and that's kind of where I landed in my brainstorm. There was, in order to have two languages work together in such a way that the decision to inline or not inline a function call could be shared, it would mean we would want a shared back end but separate front ends. And if we're going to use the linker as our, so we're talking about like the concept of language federation, which is how to make a world where you can just pick and choose multiple languages and kind of stick them together into one executable at the end. And the linker is our solution to that still right now, and it's only capable of things like eliminating entire procedures that are unused, and like very small types of inlining sometimes when it's lucky. The compiler, the optimizing backend on the compiler knows a lot more and can do a lot more. So if we wanted better language federation, it might mean that we want to build a shared backend with multiple front ends, and that a language would no longer be about going text file to object file, it would be about going text file to intermediate representation. Okay. Okay. So, right. I'm going to start by renaming those things. M for thread var link internal. Okay. So this is going to become, list all those, Mr. Forth sim comp time. Okay, so there's one of them. Link time. Nice. Now we want sim runtime. Oh, I see what's happening. Boom, boom, boom. Ugh, it's not working. It's not lined up. Boom, 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 boom. Okay. Macro fail. Oh well. All right, now for these ones, it's pretty easy. We're just putting in the extra step to go like this, and we're gonna go boom, 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 boom. It says warning. Is warning really an option? I guess it is. I've marked it that way. We'll see. First time someone hits it, we'll find out if pound warning is a... I guess maybe I just didn't know that in the forecoder lexer. But if it's real, well, it's real, we can find out like this. No, it's not real. Okay. All right, so we did the, let's go back to scratch. We did the renaming problem. Now I think I'm gonna go for it. I'm gonna say we don't want small and big. I think that that's getting confusing. And if we eliminate that, then going back over here, looking at our question about the boilerplate. Right now what I'm shooting for is boilerplate base.h and base big impl 1, right? If we get rid of big and small, then you just have to include both of these in every compilation unit, right? And maybe what you have instead is you can go like there can be different modes. So there can be Mr. Fourth, what do we just call that? Comp time, right? So we can have Mr. Fourth, inc comp time, maybe something like this. So what I can do is have a series of defined codes in base.h. So once you've included base.h, you'll have the inc comp time, and you'll have an inc runtime as well, and then or inc link time, right? And then you'll decide when you include that base.c whether you're gonna link that way. And so you would have, if you were doing static compilation, you have multiple compilation units, you would just do both of these. And if you want to do link time, you'd have one of them do this, and then the other compilation units would just do this. That doesn't quite work. It doesn't quite work because you need this in base.h as well. These could still be included in base.h to get them set up. They just can't be used before they get set up in base.h. So we would have something like you do this, and then in other usage sites you would do this. We could set this up as default, working like this, and then saying Mr. Fourth static mode or comp time mode is 1 right here, and then you would have to do this like this everywhere. Or we could say comp time mode is the default, so this would happen everywhere. And then if you wanted to, you could do define Mr. Fourth base Mr. Fourth sim link time, right? And then you could do we could just do this, right? So I could just go mark all the base functions with base func, and then you can decide to override it with link time, and then it looks like this. I like that. I like that. So what we'll do is we'll say the new system is Mr. Fourth. Now the next question is, do I do this per layer? So eventually we're going to get down to base and OS will all be rolled into, and there won't be a keywords file either. They'll all be rolled into, oh, the keywords one is kind of a bummer. I think the keywords one needs to stay separate, and I can't remember why, but I have an inkling that it was a specific reason. It was a strong need not to bundle keywords in. It was sort of keywords is separate. But say I had just this, so it's not per layer, it's for all of my code, and then I had, okay, so base will include base and OS, but then there's still going to be like let's say that I'm going to need my PRNG layer. Then here I'd be saying all my Mr. Fourth functions are defined this way unless I start redefining it, right? I could go, okay, now we're doing comp time for this one, and then you have to redefine it on a case-by-case basis all the way through to get what you want. You know what I mean? So if you wanted to intermix them, but maybe the answer is you don't want to intermix them, right? Again, if it's ambiguous, maybe less detail is better. So then the answer just becomes like, you make one decision up front. Either you do static compilation stuff like this, or you do link time resolution by doing this, and then you input in base.h, and then everything else after that just gets the thing, right? I think that's a good simplification. Let's head in that direction. So first things first, everything that says Mr. Fourth small needs to get tracked down and replaced with Mr. Fourth func. They're not all functions. It's going to be Mr. Fourth sim. Or Mr. Fourth symbol. Okay. And again, for big symbol, yes, these specifically need to be link time for the way that the profiling works. But all of these will just go together. Either you're going to do one compilation unit or multiple and link them together. Or multiple and have them all be statically separate. Well, hold on. There is a consequence. If you choose static and you actually have multiple compilation units, that does matter when it comes time to look at these things. Scratch pool. If I have two object files, and they each define their own copy of getScratch, and they each define their own copy of scratch pool. Okay, so this markup is correct in the sense that mScratchPool is a restricted variable that can only be accessed from here. But what I'm thinking is the default needs to be object linking across objects, because if you do have multiple object files, it would be a bug to not use that. Because then you would get something like on a single thread per object file, you would get a separate set of scratches, which that's a performance bug, not a logic bug. But like, look at something else that does thread var here, log, right? You don't want a separate log for each object file. You want a single log. And so they have to become linked functions. These are not just linked across object files to save space. That actually functionally matters in terms of what behavior is generated. So I think what we're saying is we're counting on See, this is where I hit this thing where I'm like, maybe all those little tiny functions won't be able to get inlines now, because you'll need to do everything as a big function. And so as soon as you got like sine F32, as a small function, or as a just generic symbol, they're all symbols now. As soon as this is just a symbol, and this has to go to linking across object files, now there's no inlining for these little thunkers. And that starts to actually suck. Although it only sucks a small amount. Let's be real. A sign is going to cost a lot more than a function call. I think maybe the answer is, if it does start to show up on a profile, it would probably first of all not be these. The part where it would matter would be something like this getting linked instead of inlined. And one way to get around that would be to stop using the helper function in your hot path and just write the low-level code that goes straight down to machine code, right? Helper functions aren't necessarily supposed to be. Helper functions aren't. This is a big thing about the base layer. It's easy to forget. Helper functions aren't necessarily supposed to be fast. They're supposed to get things done. They're supposed to be productive, right? And if you are having a performance problem, eliminating the helper functions and writing the low-level code that does the equivalent thing is always an important first step. And then rearranging that low-level code is the next step anyways. So yeah, let's go with this. We'll take the hit. We'll take the performance hit because we are forced to choose between being accurate easily and being fast easily. I'm going to choose being accurate easily. All right, let's see. Okay, so there are still occurrences of Mr. Fourth small and big everywhere that are not part of base.h yet. Just track down as many of them as we can. All right, let's try to figure that out. Base.h push explicit. Okay, so this must be about right, okay. Base small functions defined, big functions. Okay, we're gonna have to resort since I'm no longer doing small functions, big functions. I have them all sorted funny, and I'm gonna undo that. Yeah. But for starters, we just want to get them all on the same footing. If I include the .c file, I'm putting all the symbols in. And now the only question left is what's the default? And the answer is the default is link time. If you want compile time, then you do sim comp time instead. That's pretty much it. Do we have any here that are like sim runtime? None here in the header. Okay, so nothing here has been marked as runtime yet, which suggests to me that this isn't ready for action. Right, I haven't actually... Okay, so I went and did all the research on how to do dynamic linking, and I never actually got that working here in the base layer. So that's another thing I have to do. Okay. Okay. So we're gonna let this be like that. Base.c will be like that. We're also gonna look at mp4 out. That's the other compilation unit here. Base.h, base.c. No, this doesn't need a base.c because this doesn't contain a main. It is just some helper functions. It's only linking into base. It is not defining base. Right. We'll put the definition for base into with the main entry point. Min S8. Where is that defined? Right. Okay. So if these are gonna be, maybe these don't need to be symbols. Maybe these can be comp times, right? We don't necessarily need these to get linked or not linked. It'd be fine to just say sim comp time on all of these global variables. So each object file will have its own copy of these, and that won't cause any problems. That'll just be easier. W32 ticks per second. Okay, so now the problem is, since we've got the base layer working, but we wrecked the OS layer, and they're still separated right now. So in order to actually make this work, I'm gonna need to just repair the damage a little bit. This isn't set up right now for... We're not gonna be doing stuff like this. We're gonna do... This has already been defined, so you're good to go. So the only thing we need to do is mp4.out doesn't need the os.c, actually. That's the only thing. And there we go. So, boom. My flow effect still works. Probably looks like crap over the video compression, but it looks really cool. It looks really cool in the live render, I promise. All right, so I think implementation. Yeah, we don't want small OS Win32. This will just be if Windows, if OS Windows, if and if. Like that. Okay. It's a little dark in here, isn't it? I have work to do on this setup still. Let me try something. By the way, how if anyone's here been listening for the last like 5-10 minutes, how is the background noise? Is there, I know there's some traffic outside that I can hear. And I've done some work to try to minimize how bad that is, but I don't know how I don't know if it's coming through at all for you, and if it is, I don't know how bad it is. All right, so we got, yeah, that's all good. That's good. So the idea now is if you are in a single Unity build situation, no secondary object files that use base.h, right? One single use of the base library in your program in a single compilation unit. Then you could swap this out with the comp time, and it would still work. Okay. So we did this part, right? Another thing I want to do is mix base and OS. So I want to think about if I'm gonna unsort the small and big functions, declarations, base. So the way this is all set up right now, all the OS stuff comes later. Can OS come before keywords? Looks like it can. That's good. So keywords has the old school Mr. Forth stuff like function and global var. Half my code base is still in that lingo, and so this is more not really part of the library. It's more like translating from the Mr. Forth base.h style to the old school base layer lingo, so that I don't have to convert my whole code base at once. And also because I might not want to convert the whole thing. Some of the old stuff might just look and be nice that way, like, this is my personal preference. It's not very good for a reusable library base layer. This is a sacrifice I have to make things more reusable. I have to stop using things like the word function and the word read-only as global keywords. Too contentious of a namespace risk there, right? It's too much risk. So I've switched the whole namespace thing for the reusable layer, but for my personal use, I still want the renaming to these things. But not really part of the library, right? So yes, OS can just come after base. And just to be sure I did it all right, flow effect os.c can just go like this as well, right? Yeah. Okay. So now I should be able to just go something like take base layer, base declaration, start there. Here there's a bunch of stuff, profiling. Right, okay, so after profiling, we're going to drop in everything to do with the operating system layer. There's Win32 specific stuff here. So I want to go that far. Okay. Nice. Okay, so this is... There we go. And then underneath that in os.h, there's more, right? Because there's also declarations for Win32 specific stuff. And so that's got to look like this. Nice. Okay. So if we are on an OS, Windows operating system, let's see, what is this if defined function, undef function? Yes, we won't need this anymore. We'll just be able to include windows.h right away. And then we get things like Win32 main init, W32 get instance. So these are Win32 specific functions that we like to have around. Where does file write get declared, I wonder? Right, okay, so we have in our declarations of the OS abstraction, there are all these quote-unquote implementable functions, and then there's helper function, meaning something that you don't have to implement. It's just a helper. It's automatically implemented on every operating system. It's implemented once across the code base, not on a per operating system basis. Makes sense. The rest of this is the OS, the Windows OS specific. Okay, got it. So what we're going to do is in base.c, right, and so we're starting off with the sorting problem now. So let's unsort these to match over here. Macros, helpful, macros linked list, basic types, basic constants, symbolic constants, compound types, time types, file property types, arena type, the string types, log type, error type, intrinsics. Okay. Functions, numerical, math. Right, we're gonna go like that. We're just gonna start fixing this up now. So those are goods. Okay, here's another one marked small. Compound types. Functions, strings. Wait, did I have the... It looks like I had the big functions sorted in the header too, which is interesting and helpful. This is less hard than I expected. Functions time. Functions arena. C standard memory functions. Big functions strings. Sort. Log. Errors. Numerical / math again. So these are unsorted. These are incorrectly sorted. This should be up here with the other numerical math. Okay. That's the end of base.c. And if I come back down, strings, C standard memory, standard memory reserve, decommit, commit release, strings, implementable interface, right? That's not here. Profiling user interface. Okay. And so that gets us to the very bottom. We've got error accumulation end, error accumulation end. The profiling thing gets implemented elsewhere for now. Maybe that'll change, but that's the way we're doing it. So actually, why don't we do this? Declarations, profiling, // Okay. Now, os.c is sitting over here, and we have two different parts. We have OS implementation shared. This is going to be up here, base implementation. OS implementation. Shared. Okay. Then we want OS implementation Win32. Right. And that's where we're going to grab all of this. And that's pretty much it. So let's delete the OS files now. And that's all just redundant with what's in base layer. So wherever we have os.h, for now I'm just going to focus on this one program that I'm testing out, and maybe at the end of the day I'll make sure my other programs build. But we no longer need to include OS. Base just covers us. Surely you guys heard that, right? That was loud. There's no way you didn't hear that. Looking good. Looking like it works. Cool. So so those are merged. Let's do build all. This will probably expose some spots where, yeah, where we are now going to have things busted. Build all. You're out and you're out. Right. Okay, these are sim comp times because they're global variables. Although that could be a problem. No, why can't they just be symbols? I guess because they can get included twice. If they're getting included twice, then all of this is getting included twice, which it shouldn't be doing. So let's figure out what that was. That was fuzz, right? Do I have build all targets, fuzz, build fly. Do I have a fuzz build in here? Yeah, I do. Alright, we're going to have this switch over to the fuzz build real quick and work on that. So what's happening? External variable has an initializer. What's the problem? You don't like that? Why would you not like that? I guess I could. Okay, if this is gonna be a link error, if this is gonna be right, if this right here is gonna be if they are being linked across object files, then this will be a link error if it gets built twice. So I shouldn't end up building this twice. So I wouldn't need to have these marked as symbols. And if it's being built once as a single static thing, then this would end up getting static anyway. So I think I can just go sim comp time. Same logic here, right? Don't need any of this or this. Interesting. Open clipboard. It's living over here. And why would it be? Why would it be that you don't have that? That's interesting. Let's figure out which. By the way, check out the Mr. Fourth membership system if you're watching the stream. I didn't forget to tell you all about that for the last hour, but let's just check this out. User 32 lib. Okay, so if I have open clipboard in the base layer, then I guess user 32 lib is no longer just for graphical. It has to be all the time. Okay. Build all. Let's go back to fly. Build fly. Boom. Okay, that works. And build all targets. Dot, 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 dot. Boom. Dot, dot, dot. 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 Build all. Okay, podcast a scope. Build all podcast a scope. Okay, if you're gonna be like that, then you have to say, where is the thing? Is it like this? Is that how I mark them? Yeah, you gotta do this thing. Podcast a scope. This is how you gotta do it. Build all. You gotta tell it that you're graphical. Okay. But you can't. I see what's happening. Okay, build fly podcast a scope. Yeah, that's what happened. So I must have changed how I was building podcast a scope in my most recent iteration on it and forgot to update the build all targets script. Because it now links against MP4 out, so it's got to put its graphical spot right through there, and that explains it. Boom. Doot, 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 doot. Doot, 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 doot. Doot, 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 doot. Looking good. Oh, no. There's more. Alright. Killing the boilerplate lines. Simplifying the base layer. Making it easy to get started on new projects. Build all. I think we're very close. There might be one more that I missed. I think at the very bottom. Oh, two. There's two more. Boom. Boom. Boom, boom, boom. 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 Boom, boom, boom. Boom. All. Hey, okay. While we're at it, all targets should actually probably include core partial targets. D3D11 target. Yeah, let's do a BLD compile on MP4. Is that the only place where I'm actually relying on MP4? That can't be right. Build fly. Okay, so that's what's happening. The flow effect is also new. Although it's probably not going to stay, so it's temporary. Let's just throw in the animation starter. That'll go right here next to podcast to scope like this. Let's put core partial targets above core programs. So I can do BLD compile MP4 out. All right, I think that's more up to date now. Animation starter almost slipped through the cracks. Good thing I threw it in the list. Cool. Okay. I think that'll be it for today. I have worked really hard in the last couple of weeks to get the website out. So I have to take a sort of slow week. We're making progress on Mr. Fourth Base H. Honestly, this could be out anytime. Like it's getting there. The biggest things left to do are to build the dynamic linking system and to test it out. There's a little bit more work. Like if I want to get the C-label elimination ready, this could be like another month of work or so. Plus, I do want to make sure I've written some good instructions and examples for getting started with it. So I don't want to overpromise, but this is like, it's kind of getting ready. Another problem I still need to deal with, just while I'm sort of sharing. Let's look at something like podcast to scope for this. There's this other stuff that I have started pulling out into libraries as well, which I haven't announced, but I guess I'm kind of soft announcing it to y'all who are here right now. So I have other parts of the code base from the YouTube channel that I am rolling into simpler, smaller pieces. And the sound stuff is really confusing to me. So I've got like a digital signal processing section here. DSP, this never showed up on the YouTube channel, but we have things here like grabbing a signal, resampling a signal, and even like, where's the really fun stuff? Like low pass, high pass, filters, and we can do like spectrum analysis stuff. It's not fast Fourier transform. I just did like a slow discrete Fourier transform for now, but it's like that kind of stuff is here. And so that's all cool. That's fun to have. The sound stuff does like the work of, well, it's like I haven't really figured out the right way to deal with this. In order to load in a wave file, I need the low level wave stuff, and then that gives me a like a wave specific information structure, and then I want to like turn that into like a generic sound type kind of thing. And this is the level you'd use for doing things like playing it to a device or encoding it to a different file type, right? It's got the samples in a raw array. It can be different types and stuff, but it's not like chunks. So the wave is literally giving you like the file chunks, right? It's like, here's the stuff we read straight off the file, the headers, the so on and so on. Sound is more like it's an abstracted sound type now. It is in a couple of buffers, the sound samples, you're good to go. And the DSP stuff is like you have extracted specifically an array of floating point samples that you would like to do digital signal processing on. And so the interdependency here is nasty. Do I want to like wind it all up into one thing? Do I want to keep them separate and force you to include like these 4 things? I skipped over buffer operators too. Do you want to include all 4 separate just to be able to get to the point where you're going from loading a wave file to doing a Fourier transform on it? I don't know. I have to decide stuff like that. And a part of that is important for shipping the base layer. But a part of it's not. Like the connection here is I could ship the base layer without this, but like things like the keywords are still being depended on there and stuff. So like how much I want to unravel that, sort of separate. But I want to come up with a consistent way to put all of my libraries out over time, right? All of these libraries that depend on base, because these are very explicitly like they are built to work on top of Mr. Forth base. So yeah, that's more stuff coming, but yeah, that's this. I'll probably stream again, maybe every week. Plus, I might do a little bit of off stream, but like I think it would be fun to stream testing out if I can bridge this across a couple of DLLs and dealing with the problems there. It might be fun. It might be fun to stream some of the the SN printf would be cool to show, and maybe how I do examples and stuff. We'll see what I get to stream, but that's some stuff I'm going to be working on with base.h. If you want to see base.h come out and you're excited for it and you've got the ability to spare some money to support me, go check out the membership system. Here, let me sign out. Let me go check out the membership system on mrforth.com. You can help to fund my work on base.h plus other projects as I've described over here. And things like this stream and the podcast and everything are all free. So, I'm kind of counting on supporters to make some of that viable. And besides that, thanks for coming and hanging out. And I'll see you all around. Bye.